Hi, everybody. Welcome to today's webinar, Data Orchestration for the Hybrid Cloud Era. My name is Amelia, and before I introduce you to our host and speaker for today, I've just got a few housekeeping items. All participants are automatically on mute throughout the session. We will be using the GoToWebinar control panel located on the right-hand side of your screen for Q&A. Today's session will start with a presentation, followed by a Q&A towards the end so we can answer all of your questions. A reminder to ask a question, use the control panel, and please don't hesitate to send your questions in anytime, no need to wait till the end. Lastly, today's session is being recorded and will be available for on-demand playback. We will also email you a link to the presentation as a follow-up as well. That's it with the housekeeping items, so let's meet our host. I'm very pleased to welcome Peter Behrakis, who is a director at Alluxio. Peter, handing off to you.
Good day, everyone. Again, this is Peter Behrakis, and welcome to our Data Orchestration for the Hybrid Cloud Era broadcast. I'm joined by Alex Ma, who will be the second speaker in the series of presentations and communications today. Thank you again for joining. This is our agenda for today. We're going to talk a bit about the market, to do a bit of a level set to line the perspective we have on this presentation with the information we're going to be providing, so we're all in sync. We're going to talk a bit about Alexios Vision, but most importantly, what is data orchestration and how can Alluxio help you, and how can data orchestration help you? We talk to many customers in the course of each day and each week in and around, their environments and how they're trying to tackle the big data and the accelerated analytics that the business is demanding. And the first thing we run into is the legacy systems that they have. The data lakes and silos abound. And if you just look at some of those silos, there's always been POSIX data and file data. There's been database data. There's internal applications. Of course, there were data warehouses. People have started to use the public cloud and objects. And the original, probably the first generation of data lake, HDFS and Hadoop, are also in the environments that we call on. And the challenge we see they have is, how do I extract data from any one or all of these data sets and silos to run analytics to do very simple things? Much of this has grown organically. Sometimes it's been accelerated by mergers and acquisitions, but either way, it's very hard to deal with for the people that we call on who have to create the infrastructure for analytics to run their business. The trends we see that are out there we're seeing the separation of compute and storage. For a lot of different reasons, people are using the cloud, so they're automatically in a hybrid cloud or a multi-site environment. And oftentimes they may just have multiple data centers where compute is heavy in one data center and the data is heavy in another. We're seeing the rise of the object store. More and more information is being generated by machines, by applications, and it typically tends to be object. And then what we hear from technical executives is we really just want to offer self-service across the board to our, if you will, IT users at a company. So how do we wrap this all together, right? What does this really mean in a market summary? The volume and velocity and variety of data continues to avalanche according to the fourth industrial revolution, and I'm sure you experience this at your company. The business, now that it's been dealing with data lakes for the last 8 to 10 or 12 years, they're very demanding in what their expectations are to run analytics and new workflows and machine learning to drive results in their business. So they're in some ways being very hard on the infrastructure folks. We also see the Hadoop investment is being replaced by an object store or cloud investment. Some people are starting to do away with Hadoop, but at least many are starting to use the same dollars, and rather than expand Hadoop, they are moving it to cloud or object. One observation that seems very clear as well is the enterprise, the Fortune 1000 companies that we typically talk to, they're in a multi-cloud, multi-site world, and it's not going anywhere at all. If anything, it's going to become more and more fragmented where compute and storage are separated. Technical leadership wants the agility to run applications anywhere to offer self-service experience. right? To them, they want to make it transparent. And they need to do this because, as we talk to executives, they really care more and more now about compliance and security. So they have to control and centralize it, yet they have to be able to unlock the potential for the business to grow. Another theme that we see is technical organizations struggle to keep up with the data ingest and business demands that are coming from kind of the business side or the customer side of their organization. Oftentimes, IT has got less staff than it would like, yet the avalanche of data still keeps coming in, and it's hard to outpace really the amount of velocity and variety of data that we see entering organizations, because it is a race between when they ingest data and when they need to analyze and provide results to better run the business. And one thing that's also a data management struggle is the data that one has, typically to make it fast and easy and expeditious, oftentimes the infrastructure folks will just copy a whole data set, put it near the compute, and know that they've done the job. But in essence, they're copying data, and there's so much extra data around that that really it's not efficient at all. It's becoming costly. So Alexio's vision. Alluxio accelerates analytics and machine learning to enable companies to remain relevant, regardless of where the data in the compute is located. And again, as we look at how fragmented things are, this has become a big, big issue that Alluxio saw would be emerging 7 years ago when we started. And today, if we look around, we see that vision or that expectation and premise has come true. So if we're doing our job, we can accelerate analytics and machine learning 2x to 5x across the customer base that we have. So I ask you, if you're doing fraud protection or that matters in your business, if you could analyze something in an hour rather than 6 hours, wouldn't that matter? If people could do research for treatments like COVID and any other diseases that have been out there for a while, and the research could be done in 2 weeks rather than 3 months, wouldn't it matter? And a global statement, really just having better uptime for all the industrial and digital technologies that we depend on, from technologies in manufacturing, technologies in power, technologies in food processing, I mean, things that we all rely on every day. If we could do predictive analytics and just get faster results, wouldn't we be in a better state? So that's something to think about as we go through our content today. So what is data orchestration? If you go to our website, this is what we say: a platform that brings your data closer to compute across clusters, regions, clouds, and countries to accelerate results. That's what we mean by what data orchestration is. We have customers, and we have customers across a number of verticals. So while we can say verticals are very different in the way they operate, in some ways a Spark job, a Hive job, or a Presto job, or a TensorFlow job, in some ways, maybe it's horizontal in the use of the technology, and Alluxio can accelerate all of those environments. Hopefully you see something from your industry. So let's getting down to why do people use Alluxio? And it really boils down to really two, I guess the second bullet is 2 items, so 3 items. They just want fast results for the business, and while it used to work pretty good when it was all in one data center, now that there's some cloud use and or acquisitions, or there's multiple sites just because of the way businesses organically grow and move, they just need faster results. And what was once an in-data center an acceptable response time, now is across data centers and or in the cloud, it becomes not an acceptable response time for the business, and companies need help. Alluxio solves that problem for them. People also want to dramatically lower their data management, because all the time it takes to identify, copy, move, and sync data to feed the analytics engines and the machine learning engines at companies, that takes a lot of time and effort. And again, a lot of these companies are understaffed. So one thing you'll find about Alluxio, because it's a universal namespace, as I'll get into, we eliminate all the need for movement of data across sites and or your data centers in the cloud. And it wouldn't be worth it if you had to do a lot of work to get these benefits or to get these capabilities. So Alluxio drops into your existing environment without any programming whatsoever. So this is a pictorial, if you will, of compute frameworks that are at the top third of the slide. And Storage, as we note at the bottom of the slide, and the Luxio Data Orchestration, for the hybrid cloud era in the middle. And obviously it's a depiction, but what Alluxio is a software element that typically resides on the compute nodes you have, whether on-site, in the cloud, wherever it is, that pulls data from wherever the storage is to accelerate compute analytics. I mean, that's pretty much what it is. So that means we've written all the APIs to talk to all the storage, and we will continue to update these APIs for our customers. They don't have to be in the business of rewriting applications to talk to different storage. And looking at all the compute frameworks on top, there typically is a new one every 5 to 8 years. We're committed to ensuring that we can talk to those compute frameworks and optimize how we work with those compute frameworks to accelerate analytics for our users. So while we look like we sit in the middle, we're basically an abstraction layer that virtualizes all your data for all the compute frameworks you have. So you don't have to care where the data is, where the content is, as it relates to where your compute is. You can just put your compute where you're going to get the fastest results, whether it's in the cloud or on-prem. With that, I'm going to pass it off to Alex Ma. Alex?
Great, thanks, Peter. So now we'll take a look at hybrid data lakes with Alluxio, and I think first we'll start off with some of the challenges that people have in getting into these configurations. So if you take a look at it, typically what we see are 3 different approaches that people use to start running in a hybrid cloud configuration. And again, just to reiterate what Peter mentioned earlier, this is a scenario where your data and the frameworks that you're using to ask questions of that data live in different places. Right? And so there's going to be a number of reasons that you might want to do that, but when you go to do that, these are some of the things that we see. And so I think the first thing is, lift and shift. And this is obviously maybe not quite as hybrid cloud, but we're going to shift an entire application up into the cloud, and that should be fairly easy, right? But some of the things that we see with this approach when it gets implemented is that if the workload itself is not architected for the cloud, if we just lift an entire application up from the data center into AWS or GCP, the cost can get very, very expensive. And some thought needs to be taken in terms of how to optimize this for the cloud, because it is a very different approach, right? We see people try to copy data by a given workload. And again, there are tools that allow you to do this. S3 has tools. There's tools in traditional Hadoop land like distcp. And this is great if you have a workload where the data set is fixed. You can identify it out of your data lake or your data warehouse, and you can copy it. The challenge is that these things are not always as clear. You may have a very large multi-petabyte data lake, and it may be difficult to understand what it is that the users actually need for a given workload that you need to copy up to the cloud, right? And oftentimes what ends up happening is you end up copying a lot more data that you need to, just so that the workload can finish. And this is a little bit inefficient, and it also makes things a little bit challenging if you're trying to maintain some kind of sync between the data that lives in the cloud and the data that's on premise. The last thing that we see are caching at the compute layer. And this is also something that is very useful. Obviously, if you're caching up in the cloud, it reduces the amount of data that you have to transfer. But again, you run into problems with workloads where maybe you're only reading the data once. Again, maybe you're trying to sync the data with some live data on premise. And so these are all the things that become that you should at least think about when you start thinking about leveraging the solution, this paradigm of a hybrid cloud. All considerations that you have to take. Next slide, please. So in this case, Alluxio has a solution that we have that we call zero copy burst that's kind of designed to assist with this problem. And so our starting point is we've got a HDFS data lake that lives in our data center. It is very much compute bound. It is overhead heavy in terms of the maintenance operations, and we want to leverage some of the capacity in the cloud to actually do some more workloads. But the challenges are that obviously there's a network connecting these two things, and the amount of time it takes to get data up there, and the amount of data that I can actually get up there in a reasonable amount of time is it makes it kind of not feasible for us to just connect the two. Like we just talked about, copying data to the cloud is also maybe not the best solution, because now I've got multiple copies, I've got issues with sync, I've got any number of other things. And so when we look at what the Alluxio solution offers, it offers you the ability to essentially offload that HDFS data lake. Both, a lot of the work that's going to it from a compute standpoint and an I/O standpoint. It allows you to manage the hot data in the cluster. So if you've got 30 petabytes in your warehouse, and you have 300 terabytes that's frequently used, but you can't identify it, Alluxio can, right? And again, can based on the applications and their usage of data. And so what we're able to do is bring that data up into the cloud and give you performance that's like it is local in the cloud, and allow you to not have to worry about any kind of synchronization with the data that lives on premise. The other thing that Alluxio can assist you with is getting this data to more consumers. So a lot of times we work with customers where they're using frameworks like Spark and TensorFlow, and these are maybe less accessible to some of their business consumers. But Alluxio can be used to help start a data lake up in the cloud. And when you have a new data lake in the cloud with the frequently used data, you can make that data available to users through things like BigQuery or Athena, or frameworks that don't require a data scientist to necessarily run and make the data a bit more approachable and still useful. So getting more value out of that data. Next slide, please. So now we'll take a look at some of the ways that Alluxio is used in these hybrid cloud configurations, and we've actually got 3 different ones. They're all different, slightly different patterns. And the first one is Walmart. They're doing what we consider a true hybrid cloud. They've got multiple HDFS data lakes that live in their data centers, but they also have the need to support a very large team of users, about 40 teams, 3,200 users. And they actually need to run an ad hoc query service running on Presto to support these users. And so what they're able to do is they're able to leverage Alluxio to query the data that lives across all of these different HDFS data lakes. And to be able to do this transparently, they're able to leverage Alluxio so that it can start new data lakes in Google Cloud. And the end result of it, if you go to the next slide, Peter, is that we're able to dramatically increase the performance of these queries. We're able to reduce the amount of latency that it takes to actually run these things. And we're also able to dramatically increase the concurrency. And so this is especially important when you've got 3,000 plus business users. The last thing that you want to hear is that you're out of capacity, on the network side or the CPU side or the disk side, when you've got that many business users that are trying to get operational information out of the system. And Alluxio is something that helps Walmart do exactly that. If you take a look at the next slide, Peter. Adobe is another one that's also very interesting. Now, this is a hybrid cloud in a slightly different sense. Adobe ran out of room within one of their data centers and had to leverage resources in a completely remote data center. And the only way to go about doing so was to leverage something like Alluxio. They've got, very large warehouse that lives in that remote site, and copying over, petabytes or even hundreds of terabytes of data and keeping that in sync is just not realistic. And so they use Alluxio to give them a scalable solution It's a solution that allows them to efficiently utilize their very expensive network link between the sites. It's a solution that helps them scale in the way that they need to scale. And it's a solution that helps increase the amount of concurrency, again, that they can get out of the solution. And here, we've got some test results from what they tried. And so what we're looking at is combinations of, Alluxio and Presto with and without, Spark and Presto with and without Alluxio. And we see some pretty dramatic differences. These differences just get higher and higher as the concurrency or the number of users using the systems increase, because Alluxio is able to serve the data locally, like it lives in the data center, as opposed to being pulled, from 700 miles away out of a oversubscribed Hadoop cluster. Next slide. All right, the last one that we have is, again, a slightly different shift. This one is an example of Alluxio being used as a caching layer within a single cloud. And so Electronic Arts is using Alluxio within AWS to help offload, a lot of the data transfer that comes off of S3. And they've got petabytes of data that get generated by their games and users every single day. And what they're able to do is have a system that, again, leverages Alluxio and Presto to help with real-time data visualization, to help with dashboarding, to help with conversational analytics. And I think one of the issues that they first saw when they, started looking at this approach is that they were bottlenecked because loading this large amount of data was not only I/O heavy, it was also expensive from the number of calls that were being done to S3. And so what they're able to do is leverage Alluxio in a way to help cache against S3 and increase their performance anywhere from 2x to 7x, depending on the type of queries they're running. One of the immediate benefits to this is obviously, or one of the reasons for this is the ability to cache data locally, within the Presto workers. The other benefit is not as obvious. It's actually caching all the metadata calls that go to S3 as part of these queries. The way some of these modern frameworks work, they have to do recursive listings, they have to do lists of statuses for given files or directories, and what that can end up translating to within a given query is something, we often see several tens of thousands of requests in terms of API calls going out per query, and these things are negated when they're going through Alluxio because Alluxio can service that request and offload it from S3. And this helps, both from a performance standpoint, but it also helps from a cost standpoint because S3 usage is actually priced on a number of components, one of them being number of calls going to S3. Next slide, please. So we talked a little bit about the challenges of hybrid cloud. We've talked a little bit about how some customers are using Alluxio. Now we're going to talk a little bit about, some of the internals of Alluxio and how it actually helps provide, some of these benefits. And the first thing that we're going to look at is data locality, right? And so Alluxio acts as a caching layer for these big data frameworks, these things like Apache Spark and Presto and Hadoop. And it does so by leveraging leftover resources on those machines so that Alluxio can create a dedicated caching layer on that machine. And it's flexible. It can work with whatever that you have remaining because, some of these things are bound on different things. Applications that leverage TensorFlow are typically going to be very GPU heavy and may not use as much memory. Things like Apache Spark may use a good combination of both, but whatever it is, you can actually configure Alluxio so that it has some percentage of memory, some percentage of SSD, or some percentage of spinning disk to actually store the data, and again, leverage it so that it doesn't have to reach out to a data lake that might be remote, to an object store that might be local. You're able to cache data locally, and Alluxio can intelligently manage the migration of that data across these different tiers for you. Next slide. In terms of keeping up in sync, we leverage a concept in HDFS called iNotify. And iNotify is essentially a way that Hadoop can broadcast out what changes are happening on the file system. And Alluxio is able to tap into that so that when my query on Presto is running and I'm looking for, the most up-to-date information for my dashboard or for my report, Alluxio can tell that query, hey, I've got the current data, I'm going to serve this request, or hey, actually this file has been changed, and I'm going to go fetch it for you automatically and then service it to you just so that you can have, again, the best results. And so what we have the ability to do is not only tie into that, but give you the option to decide whether or not you stay in sync and the level of frequency that we check with, right? Next slide. Policy-driven data management, we have a couple different concepts in here. And so I'll actually start off with the first one because it ties into kind of what we're looking at. And so the first concept, again, for why Alluxio can help with these things is the Alluxio unified namespace. And so what you can see here is a very complicated looking chart. And if we focus on the green boxes in the center, they represent the file system as Alluxio presents it to a given application. So an application accesses Alluxio, it sees data and users, and it sees reports, sales, Alice, and Bob underneath those folders. Now, what the application is completely agnostic to is the fact that the data from the first side of things is coming from an HDFS data lake, and that the data coming from the data folder is actually coming from S3, and in this case, also another HDFS cluster. And so the first value that Alluxio provides is the ability to kind of unify all your data silos and present a unified namespace for the applications to really simplify how they go about accessing data. It doesn't need to know that, hey, this NFS server has this piece of information and this, object store has this piece of information. It's able to just kind of seamlessly access it and manage that data regardless of where it lives. So, it maps very closely to something like LVM, if you're familiar with the concept in Linux, a logical way to represent physical devices or physical locations. So to tie on to that, we actually have a few other features that are interesting. We have the ability to essentially mount, these remote storage layers and present them as locations in Alluxio. And in this case, what we're doing is we actually have the ability to mount multiple locations and present them as a single interface. And so what policy-driven data migration does is it takes advantage of this concept and allows us to have the data folder mounted to both a HDFS directory as well as an S3 bucket. And the reason why I might do that is I might want to say, hey, HDFS is my source of truth, and S3 is kind of my archival layer. What I want to happen is, hey, if I haven't touched this data, in a week, I want it to migrate to S3. And so you can actually create policies in Alluxio to copy or move data based on certain actions. And that can be very useful when you're going to, try to get a very large number of files out of your HDFS cluster and migrate them off to a less expensive object store, or when you're trying to create a new data lake up in the cloud. Next slide, please. So we've been talking a lot about Alluxio. Sometimes a picture helps in terms of what it looks like. Perfect. This lays out kind of a typical architecture that you might see of Alluxio in a production environment. And so we've got a couple different things going on here, but like these long rectangular boxes represent multiple machines. And typically what you would do is you would have a number of, let's say, in this case, Spark or Presto, pick whichever one is more relevant to you. But you would have those workers installed on, instances on EC2, and they would be running. And what we would do is we would install Alluxio workers on each of these machines. The Alluxio workers are configured with, hey, you've got, an extra 20 gig of RAM that I will allocate to you, or you've got this SSD volume that I'm going to allocate to you, whatever it is, somewhere that the Alluxio worker can cache data locally. There'll be an Alluxio master that lives somewhere in the environment, and this helps to route requests. And so we take a look at the path of data as it flows. Spark or Presto, they're going to ask a question. They're going to say, hey, I want to access this this Parquet file. I need to check it for metadata, or I need to do a query against some of the data in that file itself. And so that Spark, that framework is going to ask the Alluxio client for that information. The client is going to look at the Alluxio master and say, hey, I need access to this file. And the master is going to say one of two things. It's going to say, hey, I've already got that piece of data. It lives on this Alluxio worker. Go to that worker to service the request. Or I don't have that data. I'm going to tell the closest worker to you to go fetch it, right? When that request goes to an Alluxio worker, it is going to reach out to the remote storage layer and pull that data back for you. And it can do so in very, very intelligent ways. We can actually do so asynchronously for some requests, and this actually makes a lot of sense when you have like a large Parquet file, and Presto's just trying to scan it for metadata, the footer of the file, so that it can figure out its plan. You don't want that scan to wait to pull down the entire file. You want to pull down the footer of the file so that you can understand what's going on with it, and then maybe asynchronously pull down the rest of the file to Alluxio in the background so that it can service the request when the query comes in. And so it's able to essentially pull all that stuff automatically for you and continue to service the requests. This is kind of what Alluxio looks like, living in a production deployment. The workers are typically going to be installed alongside the workers for the big data framework that you're using. The Alluxio cluster itself will be configured to tie into your remote storage. And once that's configured, it'll be able to seamlessly present data and service data requests to these applications. Next slide, please. So another new feature that came out recently this year is the Alluxio Catalog service. And a lot of the times, Alluxio works, primarily with files and objects, going directly against the object store or directly against the HDFS. But I think one of the things that we realized was that there was a slight impedance mismatch when you start talking about things with metastores, things like Hive or things like Glue. And so what we came up with is the concept to be able to abstract database catalogs in Alluxio so that, again, we could provide that seamless access. If you click next, Peter. So one of the things that this dramatically helps with is massively simplifying the deployment of Alluxio. We're able to tap into the metastore. We're able to understand locations of where all this data is, and we're able to seamlessly translate those locations into Alluxio locations so that onboarding Alluxio in a production environment where you've already got a bunch of stuff running is much simpler. We're also able to help with optimizations. And if you take a look at the next slide, these optimizations come in the form of two different things. They come in the form of coalescing data as well as converting data. Now, a lot of the users that we work with, they'll have regular batch uploads of comma separated value files going into their data lake, right? And, a lot of these querying frameworks can still work with them, just fine, but they typically work with them better if they're not looking at a very large number of files. And so what Alluxio can do is it can actually help coalesce those files from many to one and do so automatically for you, right? The other thing that it can do is it can also help with format conversions. So CSV, again, is a very typical way that people store data, but it's maybe not the most efficient way to query data, right? If we're taking a look at, a very wide set of columns within the CSV, for me to ask a question of a single column, I'm reading the entire file. Versus if I store it in a column format like a Parquet or an ORC, see, it can be much more efficient from a query perspective because I'm using an optimized format. I'm looking at a lot less data. And so Alluxio can actually help with the format conversion as well, going from storage optimized formats to compute optimized formats so that your queries can be efficient, and it can handle this all automatically for you. You go to the next slide. We'll skip one more. Keep going, Peter. There you go. Okay, so we'll talk to this one. So in this example framework, what we're doing is we're essentially taking a Hive metastore and we're attaching it into Alluxio as a catalog. And Alluxio is then servicing that data to Presto. And what we're able to do is ease the onboarding of that whole process. And we're also able to make things more efficient by coalescing a large number of CSV files. I think in this example, it's about 10,000, and converting those CSV files into Parquet. And so you can see some of the differences between the two. So Presto going against CSV through Alluxio, the query takes 70 seconds or 20 seconds. Alluxio transforming that into Parquet, we get down to 7 seconds. And then lastly, Alluxio transforming it along with caching that data, we get down to 3 seconds. So some really interesting things that can be done to help make your life a little bit easier when servicing some of these workloads. Next slide. So that was a good overview, I think, of kind of the state of some of the things that we see in the hybrid cloud, some of the challenges of actually getting to a hybrid cloud configuration, and how you can actually go about using something like Alluxio to help with that problem. So let's pause here and see if there are any questions on the line that we can address for you.
Yeah, this is Peter. I'm checking right now. So let's see. Yeah, we have one question. Does Alluxio work with machine learning?
Yeah, so that's a great question. I know in this talk we focus on Spark and Presto a lot, and partially that's just because those are some of the things that we see most frequently. But if you take a look at the existing slide deck that we had earlier, and you don't have to shift to it now, but Alluxio actually interfaces with a very large number of technologies, and some of those are definitely in the machine learning space. So Caffe, PyTorch, TensorFlow, SparkML, all of these things tie in well with Alluxio, and we actually have some really interesting blogs on our website about how people have used Alluxio to help accelerate machine learning training. And so some really interesting patterns there, just because when you're doing these training, it's kind of the perfect scenario to have something like Alluxio, because you're trying to feed a GPU, you're doing it with multiple iterations. Having something like Alluxio adds a lot of benefit in terms of enhancing the model training time.
Yeah, and for whoever asked, we actually have a case study where someone was using machine learning and saw 4x acceleration. So we'd be happy to provide that to you. So the next question, let's see, regarding EA and S3, question is, so is one of the costs being avoided ingress egress? It sounded like it's acting as a cache, so that would make sense. Again, EA was the all-in cloud use case. Alex, any thoughts?
So for EA, not as much, just because it is, like you just said, Peter, all in cloud. But in the case of Walmart, very much so. So in the case of Walmart, if you're just doing read workloads, that's one thing. Obviously, having a cache is going to help with ingress. But if you're also trying to write these results back down to the remote site, you're also trying to help with, offsetting those temporary writes that would otherwise translate into egress costs. And yes, Alluxio definitely helps with both ingress and egress in that kind of scenario.
So we help, but maybe in that scenario, that wasn't necessarily the win for EA.
Not necessarily the win for EA. I'd say the win for EA is around a couple things, right? One is just the caching benefits of caching data from S3, as well as being able to cache the metadata from S3, right? Those two things combined translate into very large increases in query performance. And so that just extrapolates out. You can run the query 2 to 7 times faster. Your dashboards run better. Your users, your business users that are running ad hoc queries, they're happier because these things take less time. From the operational side, we're also no longer going to S3 for a very large number of these metadata calls, right? And so that can get expensive on its own. We actually have an interesting blog up on our site as well, where one of the users actually mapped out kind of exactly what they were saving. I think that user was Wright, R-Y-T-E. But it's a really in-depth article that walks through kind of the exact calculations of what they were seeing and how Alluxio can help with this thing that usually you wouldn't really think about, but that shows up as an added component under your S3 cost.
Yeah, that's great. Thanks. And on a lighthearted note, with all the things that are going on, a lot of us still at home, gaming might have become even more important now that we're all at home for some segment of the population. So another question from attendee, any plan to support Delta Lake format in Alluxio?
I'd have to check with kind of our product team to see if we have a concrete date or any milestones. But from what I remember, the Delta Lake format is comprised of two things. It's comprised of data stored as Parquet, and it's comprised of a transaction log that I think is stored in JSON. I forget exactly which. But one of the interesting things about Delta Lake is the two combined things give you a lot of interesting capabilities against that format. But without the transaction log, you're still able to access all the data that lives as Parquet on wherever you're storing it. And so what I'd say is, we obviously don't tie into the transaction log today. I'm calling it a transaction log. It may actually have a different name, but we do definitely read Parquet files on whatever format you're storing it on. So I'd say it's a partial. We don't fully support it now, but we can. Delta Lake stores data in a format that Alluxio can definitely work with.
Very good. Another question was, how does Alluxio integrate with data governance tools like Ranger?
Sure. So I think of Ranger as Apache Ranger, the HTTP project for managing access to data. Alluxio actually integrates with Ranger. And so in an environment where you are using Ranger, Walmart is actually using this exact stack, Presto, Ranger, and HDFS and GCS. But essentially the Presto query sends its request to Alluxio. Alluxio is tied into Ranger to see if that Presto user that's making the request has access to that data, and if so, it allows the request to go through. And so it's a good question, but we do work with Ranger, and so it flows in the path of the security toolchain.
Another question. Let's see. Hold up. How does Alluxio know to perform the right compaction action? Can I automate it? And does it get parameters?
So I'm not 100% sure what you mean by compaction action. If you're referring to the coalescing of CSV files that the catalog service is able to do, you definitely can automate it. And I think there are some parameters that you can pass to it. I forget exactly what it is, but you can find it in our docs if you're interested in, what if you want to set a specific chunk size or something like that. I believe there are some options there, but I just don't remember off the top of my head.
Okay. Let's see, how do you determine a cache hit? Can I fetch data and get the wrong date?
Yeah, so a cache hit is very simple. I mean, what you're doing is essentially making a request for data, and that data is either in Alluxio or it's not in Alluxio. And so if you make a request for something that was recently accessed by someone else, that's likely going to be a cache hit. If not, it's going to be a cache miss, and we're going to have to fetch that data from the remote store. And so in terms of the wrong date, it's ultimately up to the application. But to answer the question, there's a couple ways of doing it. It can be deterministic based on the data that you're requesting from the application, but you can also optimize it by preloading the data in Alluxio. And I'll give you an example. If you as an example do a daily upload, and that upload translates into a partition within Hive, and Parquet files that are stored in an object store, you can actually tell Alluxio, hey, I want to preload this partition file in Alluxio so that when my users come in the morning, that data will be hot, so that I can predetermine a cache hit as opposed to a miss.
I think it's okay to cheat a little bit with cache, isn't it? Just pre-populate.
Yeah, I mean,
sure.
Yeah, optimizing is
okay, so here's one. We found Presto usually use a lot of systems memory. When we run query on HDFS, will Alluxio help on that, like performance versus memory utilization trade-off?
Well, I mean, it's a tricky question. I mean, Presto does consume a good amount of memory on the system, and Alluxio is not necessarily going to help with that. So what I would say is that, when you're running that query on Presto and it's using a given amount of system memory, that is not specifically going to change, if you add Alluxio into the picture. I think what will change is the ability for some caching benefits to happen for HDFS. And so we'll help offload some of the IO that is happening on HDFS itself and help with the latency and concurrency of that query being run. But Presto is going to continue using the same amount of memory that it was before.
Yep, got it. I think I can take this one. Are you only supporting object storage? What I'll say is no. I think on one slide we had a bunch of different storage options that we've written APIs to connect to, and there are POSIX for file, there are object, a variety of sources, there are multiple cloud, Azure and GCP and AWS, of course S3 for what I'll call on-premises object. And so that's really our goal, and that's really a big thing that we invest in all the time. And as a partner of our customers, they don't have to rewrite their apps to a particular computer interface or a storage interface. That's really what Alluxio can provide for them. And what seems to be very popular now and moving into the near future is people wanting to get off Hadoop with its own interface and move to S3 for a variety of reasons, right? And they don't have to rewrite their apps, because if they're using Alluxio, we will translate that from HDFS to S3 with our customers not having to do anything. So for a lot of people, that is a big elimination of a barrier to move in a direction that they want to move in for whatever the reasons, agility, cost, scale, whatever. So let's see, anything else? What about having update data? Is Alluxio, or does Alluxio have limitation in this area? It's a little vague, but can you make something out with that, Alex?
Yeah, so I can think of that in two different ways. A lot of the benefit of a cache is obviously if you're reading data, but maybe the question's geared towards what if I'm writing data? And then the second way I might think about it is, what if this data is changing on the system that I'm reading the data from? How do I keep in sync? Right. So we'll tackle both those possibles. So in terms of keeping up to data that's changing on the remote data lake, one of the ways that we talked about was the metadata sync interval, or sorry, not metadata sync interval, but the iNotify parameter within HDFS. And that's a framework that we can tap into to keep track of updates that are happening on that remote data lake, so that we know essentially if there's up-to-date information in Alluxio or if that information's out of date. The other thing that you can do is you can actually set a specific synchronization interval. And so what we'll say is, if you know your data changes daily, we can say if the data that if the metadata that Alluxio has for this file is, this old, consider it good. But if it's older than that, reach out to the remote store and verify that we have the correct stuff. So you have a lot of different options in terms of staying up to date with data that might be changing underneath the hood. Now, when you talk about using Alluxio in scenarios where you're not just doing reads, you're also doing writes, there are, again, a lot of benefits. And so Alluxio can help with things like the temporary writes that you might need to do on Spark workloads, where I have to store down my results somewhere, and I don't want to have to write them down to the remote store. I don't want to have to write it to something like an object store where I'm going to have to rename it later, because those operations are a little bit different in an object store versus a traditional something like HDFS or NFS, and it's actually a copy operation instead of a rename. But there's a lot of benefits there, because Alluxio can be used essentially as a temporary in-memory buffer to help accelerate all those writes. So you still have durability. Your operations are still able to pick up where they left off, with another thread or another executor, but you're not taking the latency cost of doing that write to a slower remote store, or doing it to a store where that operation is going to be more costly from a latency perspective. I think the last thing that's really useful is that, again, if we're persisting a large amount of data, that application is typically going to have to wait for that operation to finish. And Alluxio can actually be configured to persist this data down asynchronously. So your thread or your application can continue doing what it needs to do, and Alluxio can take care of writing it down to that storage layer at whatever speed that storage layer is capable of accepting that write. So a lot of different options for helping out for not just read workloads.
Yeah, when I think back to the previous question about not having to rewrite applications to move from HDFS to S3, another thing I forgot to mention is people are all wondering, okay, we want to do it, but are we going to end up with a lot less performance, and how is that going to impact our analytics workflows? And having a caching layer obviously eliminates their concern, right? We can in some cases even have the performance be better than what they were used to. Okay, I think we have time for one more question, and it's regarding security. How was the security design behind? How was the privacy for data?
Sure, good question. So we support a number of things in kind of the Hadoop ecosystem when it comes to security. And so I think the first thing to understand is that Alluxio supports kind of a POSIX security model. So you can set permissions at the owner, group, and world level. You can also set fine-grained ACLs. For Alluxio, the permissions can really come from one of two places. You can set them within Alluxio so that they can be respected by things accessing that data, or Alluxio can inherit those permissions from something else, right? Something like a ranger, so that we can understand, we can tie into what you already have from the existing standpoint. So that's one. I would say the second thing that is kind of useful is what it allows you to do from a security standpoint is actually apply some of those things to object stores, where the concept of a group or an owner may not necessarily exist. And so you can apply group level permissions at the object store layer and tie that into your security, your access management system. Maybe you're using LDAP or Active Directory, and you could say, hey, this group exists for data, and this object on this object store is set at the group level and tied in with your existing frameworks. So it's actually a nice option for object stores because it gives you a way to tie into the existing enterprise security framework in a slightly different way. And so that can be very interesting. But that's a high level of how we cover security and privacy for the data itself. I think the last thing to mention is that we support impersonation as well. And so, Alluxio can run in multiple modes, but it can also pass down or pass a request with a given user specific permission if needed. So that was the last point.
Well, we might have time for one more, so we have a few minutes. So what is the average cache hit percentage you see in your workloads? Because if it's too low, the users will actually experience latency as if the data is remote, and that would be unacceptable, right? So it kind of brings up a good point on hot, warm, cold cache.
Yeah, it definitely does. I think the type of application and the type of users are very important to consider when using Alluxio and what you're trying to get out of it. So it's going to be very different, obviously, if your analysts are looking at, say, the last quarter's worth of data, right? And that's a very tight timeline. And so for something like that, you can actually size Alluxio such that it would fit that quarter's data so that you're not having a cache miss. If you contrast that with something like, users running open-ended queries, where they might say, hey, I'm interested in the last 20 years worth of data, and it's going to be a huge hit against your data warehouse, that's obviously a very different type of workload to be run. And so what I would say is we actually see, both types, right, within Alluxio. And depending on the type of usage, the user is going to size the Alluxio cluster such that it has capacity to be able to minimize the number of cache misses for a given workload by keeping the hot data within Alluxio. And so, the average cache hit is going to vary. But what I'd say is, like, on average, I see anywhere from, users have, anywhere from hundreds of terabytes to several tens of petabytes of data. And what I'd say I see anecdotally is that usually they're interested in anywhere from 1 to 10%. And 10% is like way on the upper bound, right? But usually it's, in the single digit percentages of that overall data set that is hot, that users are actually, accessing frequently. The tricky thing obviously is identifying where that 1% is. Is it in this directory? Is it this partition? Where does it actually live? And that's something that Alluxio is very good at, because what it's doing is it's just translating the application's request into bringing something into cache. And so that 1% kind of naturally gets into Alluxio, and that obviously helps minimize the percentage of cache miss. But again, the use case is important, the sizing of it's important, but that's some of the things that we see at a high level.
Well, that's great, Alex. Thank you. So this will conclude our time with you today. We want to thank you very much for investing your time to check out data orchestration from Alluxio. If there are follow-on questions or comments, please send an email to me at peter@alluxio.com, and we'll make a point to answer your questions and help guide you on how you can accelerate your analytics and machine learning workflows. So from everybody here at Alluxio, thank you again for joining us. Have a great day and be well.